here's our review of Kramers rule, and the first thing we need to do is we got to find the discriminant of a 2 by 2 matrix. And it's pretty simple. We're just going to multiply diagonal. It's very important though that top left and bottom right go first, and then we subtract the bottom left times the top right. Alright, so this is what it would look like. 2 times 5 minus 3 times 1, and my determinant would be 7. Here, we're going to go 4 times negative 2 minus negative 5 times 7. We got to make sure we don't lose negatives. Negative 8 minus a negative 35, and that becomes 27. Now, why that's important is that's going to allow us to find the systems of equations. So, essentially, this is 1 right here. I'm sorry about that. It kind of got mixed up when we did the typing of it. But essentially, I'm trying to find 2x plus 5y equals 1 and x plus 4y equals 2. This allows us to solve systems of equations. Now, I'm going to do systems where the answers are not going to be complex fractions, but this actually is a very valuable tool when it does become a complex fraction. Okay? Because doing it by Kramers rule makes it a lot easier to get the fraction because you don't have to plug anything back in. So if you get an answer like x equals 2, that's easy to plug back in. But if your x equals 25 over 37, that's much more difficult to plug back in. So here's what we do. We create 3 matrices. The first matrix is just the coefficients, 2, 5, and 1, 4. And you notice 2, 5, and 1, 4 here. Then what I do is I replace the x column with the answers or the numbers to the right of the equal sign. So 1 and 2 is to the right of the equal sign. So it's 1, 2, and then I recopy that second column of y coefficients of 5, 4. And then I recopy the x coefficients of 2, 1, and we put those numbers to the right of the equal sign to replace the y coefficients 1, 2. So how it works every single time is our first matrix is always the coefficients. Then we replace the x column with 1, 2 for our second matrix, and then replace the y column with 1, 2 for our third matrix. And we take our 3 determinants. 2 times 4 minus 2 times 4 minus 1 times 5 is equal to 3. And that becomes our denominator. Our x coordinate, or our x value, is going to be the determinant of this matrix over the determinant of my original matrix. 1 times 4 minus 2 times 5, which is negative 6. And what I do is I take this determinant and I put it over the determinant of just the coefficients. And negative 2 is my x value. So this represents x. And down here, we have 2 times 2 minus 1 times 1, which is 4 minus 1, which equals 3. And now I put that over the determinant of my coefficients. And 3 over 3 is 1, and that's my y. And you can plug these back in to check them. Negative 2, 1. Watch what happens. 2 times negative 2 is negative 4. 5 times 1 is 5. Negative 4 and 5 is 1. Negative 2 plus 4 times 1, negative 2 and 4 is 2. Second one, my coefficients, 2, 3, 4, negative 2, and there's my 2 by 2 matrix. 2 times negative 2 minus 4 times 3 is negative 16. Then we have 2, 4. Sorry about that. This kind of got messed up here. Fix that. This is, we replace the x coefficients with 13, 2, and we keep the 3 negative 2. 13 times negative 2 minus 3 times 2 becomes negative 32. And if you look, negative 32 over negative 16 equals 2. So my x equals 2. And then my bottom one, 2 times 2 minus 4 times 13. we get 4 minus 52, which is negative 48. Negative 48 over negative 16, my y equals 3. So x is 2, y is 3. 4 times 2 plus 3 times 3. I'm sorry, 2 times 2 plus 3 times 3. That's 4 and 9 is 13. 4 times 2 is 8. 2 times 3 is 6. 8 minus 6 is 2. It should work out on every single level. Okay. And then finally, 5 times negative 7 minus 3 times a negative 3. Negative 35 plus 9 is 26. I replace that x column with 11, 17. We keep the y column of negative 3, negative 7. And we get 11 times negative 7 minus 17 times a negative 3. 77 minus 51, or negative 77 minus a negative 51 gives me negative 26. Negative 26 over 26, my x equals a negative 1. Finally, 5 times 17 minus 3 times 11, that's 85 minus 33, that's 52. And 52 over 26, my y equals 2. X equals negative 1, y equals a. Sorry, I apologize. I gotta fix this here. Negative 35 minus a negative 9 is a negative 26. So that makes this a positive 1. So my x is actually 1. And now as I fix this, my negative 26, my y becomes negative 2. So my answer is actually x is 1, y is negative 2. I apologize for the earlier mistake. So 5 times 1 is 5, negative